Now, in this video, we are going to take up one more problem on projections of laminas. How to analyze it in 3D and solve this problem by using manually. The problem reads as a hexagonal lamina of sides 25 mm rests on one of its sides on VP. The side opposite to the side on which it rests is 30 mm in front of VP, and the side on which it rests makes 45 degrees to HP. Draw its projections. Also determine the inclination with the reference plane. So to do that, so initially we are going to consider as the lamina rests on VP. One of the sides is resting on VP, so make that side perpendicular to HP. So when you make the lamina perpendicular to HP, so what happens when you look from the top view, it will be resting on HP here. It is resting on VP now. So now, perpendicular to HP means when you look from the top view, you must get a point. The side opposite to the side is also a C dash D dash. So here, when you look from the front view, the image will going to be on VP because he says one of the side has to rest on VP means what? It should be, all the sides has to be rest on VP. Then only you can make one of the sides resting on HP. And here you can see all the sides are parallel to VP. Since all the sides are parallel to VP, therefore in vertical plane you can see the true length. That is A dash, B dash, B dash, C dash, D dash, E dash, E dash, F dash and F dash A dash. All are equal to 25 mm. So that will going to be the true shape. And what is the position of this lamina with respect to both HP and VP? The lamina is parallel to VP and perpendicular to HP. Since the lamina is perpendicular to HP, you can see in HP you are getting a line. As we look from the top view, A dash, B dash, C dash is near to the observer, so ABC is visible, D dash, E dash, F dash is away from the observer, so therefore it is in bracket. And here, both all the sides are resting on VP and resting on VP. Now, how it is possible, how we can be able to write it in manually? First, we are going to draw the XY line and you mark VP and HP. So, initially, you draw a vertical line of any distance, and by using the compass, you take a radius of 25 and you take any point on this vertical line and draw a circle, a thin circle of radius 25, such that it will cut this vertical axis, it cuts this vertical line at 2 points, which will going to form the diameter of the circle. So here you mark that point as B dash and you mark this point as E dash. Then with B dash as center, take a radius of 25, cut an arc on the circumference of the circle on the left side and also on the right side. Similarly, with E dash as center, take a radius of 25, cut an arc on the left side and also on the right side. And you mark these 2 points as F dash and D dash. Then you join A dash to B dash, B dash to C dash, C dash to D dash to E dash to F dash, and F dash to A dash with a dark line. So this is how you will be able to draw a hexagon of 25 mm sides. Once you do that, then you project from A dash F dash, draw a vertical projector to the XY line. Similarly, from B dash E dash to the XY line, and similarly from C dash D dash to the XY line. As you look from the top view, ABC is near to the observer and D dash E dash F dash is away from the observer. Therefore, DEF is in bracket. Then join, as we have joined between A dash B dash and B dash C dash here. Similarly, you join between A to B and B to C with a dark line. So this is how you will be able to write the initial position of the front view and as well as the top view. Now, in the second position, what he says that one of the sides is resting on VP. The side opposite to the side, which is the one of the side is resting on VP, A dash F dash is resting on VP, and one of the sides is on VP, while the side opposite to the side is CD, which is away from VP by 30 mm. You can see that it is 30 mm here. So here the inclination is not given. Since the inclination is not given, so we need to find out that particular inclination. So then how to proceed with this particular problem? So you rotate the initial position of the hexagon till that C dash D dash becomes in front of VP by 30 mm. But now CD, which is on VP, you rotate that till it becomes 30 mm. As we rotate this, what happens? The image on the horizontal plane is getting rotated. So you can see that CD is in front of VP by 30 mm. As you look from the top view, here the surface is inclined to VP and perpendicular to HP. So that is the reason why you are getting a line in the horizontal plane. As look from the front view, B is projected onto vertical plane, C is projected onto vertical plane, D is projected onto vertical plane, E is also projected onto vertical plane. So as you look from the front view, this A dash, B dash, C dash, D dash, E dash, F dash is the image what you get. The image what you get, the front view of the image what you will going to get in the front view in vertical plane. As you look from the top view, since the surface is perpendicular to VP, so perpendicular to HP, therefore you are getting a line in the horizontal plane. And this is how you will be able to analyze in second position, front view and top view. How to write that now? So take any convenient distance from the first position top view to the second position, and you take it, mark a point on the XY line. You mark that point as A and F in bracket. Then from XY line, you measure 30 mm and draw a horizontal line. Then by using the compass with A as center, taking the radius of EC with A as center, cut an arc on that horizontal line which is 30 mm in front of VP. So then join, then you mark that point as C bracket D. So that means the side opposite to the side is 30 mm in front of VP. So then join between A to C directly with a dark line. Then by using the compass, you measure the distance from A to B of the first position top view. In the second position top view with A as center, cut it on that inclined line what you have drawn, and you mark that point as B bracket E. Then by using the, now you project from A dash, draw a horizontal projector from A dash C dash of the first position front view to horizontally. Then you draw a vertical projector from A and F to the top view, front view. Similarly, draw a horizontal projector from F dash and D dash and draw a vertical projector from C and D to the front view. Then these two lines will going to intersect at this point which is A dash. We mark that point as A dash. Similarly at this point as C dash, and similarly at D dash is in front at this point and F dash at this point. And similarly draw a horizontal projector from B dash and also from A dash, and draw a vertical projector from the second position top view to the front view, and these two lines will going to intersect at this point. You mark that point as B dash and you mark this point as E dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash to A dash with a dark line. So this is how you will be able to write the second position, front view and also the top view. And the side which is resting on HP is inclined at 45 degrees to the side which is on VP is inclined at 45 degrees to HP. Since the inclination given is the true inclination, and first we need to check whether this edge is in true length or not. The edge which is, how do I know that the edge which is in VP? We can see in the top view that edge is on XY line, that is in vertical plane. So since it is on vertical plane, both A and F are parallel to VP. Therefore, A dash F dash will be in true length. What is the length of the true length? Here it is 25 mm. So here also it is 25 and here also 25. Therefore, this line is in true length. And also the inclination is given as the true inclination. Therefore, what I can do is we rotate this edge in 3 dimension by an angle of 45 degree in the third position. So this is how you will be able to see that particular object in 3 dimension. So such that this AF has become inclined at 45 degrees to HP. So as you look from the front view, B is being projected onto the vertical plane. Similarly, C, D, E and F is already on VP. So you will going to get the position here, and then as you look from the top view, and you will going to get this as the image what you will going to get when you look from the top view. So this is how you will be able to analyze this in 3 dimension. Here the length what you have is the true length and the inclination given is also true inclination. Therefore, you rewrite the same sketch by you are rotating this object, you are rotating this lamina by inclining at an angle of 45 degree with respect to HP. Now in this position, the hexagonal lamina with one of the sides is perpendicular to HP and it is on VP. So therefore, and it is parallel to VP and perpendicular to HP. Therefore, in the top view, you are getting a point. And as we rotate this by an angle of 45 degree with respect to HP, this point will going to become a line you can see in the top view, because A dash and F dash will be, these two are different points now. So therefore, you are going to have a length. Since it is inclined to HP, you will going to get the apparent length here. But since it is parallel to VP, therefore you are getting the true length here. So this is how you will be able to analyze it in 3D. And now how it will be possible to write it. So once you know that this edge which is on VP is parallel to VP, you are getting the true length. And the given inclination, the edge which is on VP is inclined at 45 degrees to HP. Therefore, you are getting, since it is the true inclination and the length what you have here is the true length, therefore you rewrite the same sketch by rotating at an angle of 45 degrees. So to do that, what we must do now? So you consider any point and draw a horizontal line. Consider any point from that by using the protractor with reference to that horizontal line. You measure an angle of 45 degrees and draw an inclined line. Then you, by using the compass, you measure the distance from F dash to A dash and transfer it from that 45 degree line. And you mark this point as F dash and you mark this point as A dash. As we know that from A dash you have a horizontal projector, similarly from F dash also. Then by using the protractor with reference to this line A dash F dash, with A dash as center, you measure an angle of 90 degree and draw a line perpendicular to A dash F dash. Similarly from F dash also, by using the protractor, you measure an angle of 90 degree with respect to A dash F dash and you draw a perpendicular line. Then by using the compass, you measure the distance from A dash to C dash, which is same as F dash to D dash, and transfer it from A dash on this vertical projector, that is on perpendicular line, similarly from F dash. Then you mark this point as C dash and you mark this point as D dash. Then by using the compass, you measure the distance from A dash to this point and transfer it from A dash on this, similarly from F dash on this, and joining between these 2 points and extending it on either side. Then by using the compass, with this as center, taking the radius from this point to B dash and transfer it from this point towards the left side, to mark that point as B dash. Similarly, you measure the distance from this point to E dash, which is same as from this point to B dash. So from here, you transfer it on the beneath side and you mark this point as E dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash, F dash to A dash with a dark line. So once you do that, now we have able to rewrite the second position front view by rotating at an angle of 45 degrees to HP. Then you draw a vertical projector from both A dash and F dash to the XY line because AF is on XY line. You mark this point as A, you mark this point as F. Similarly, you draw a horizontal projector from B and E to the third position top view. Draw a vertical projector from both B dash and E dash. These two lines will going to intersect at this point and also at this point. You mark those 2 points as B and E. Similarly, you draw a horizontal projector from C and D to the third position top view and draw a vertical projector from both C dash and D dash, and these 2 lines will going to intersect at this point and also at this point. You mark this point as C and you mark this point as D. Then join A to B, B to C, C to D, D to E, E to F and F to A with a dark line. And so this is how you will be able to write the solution on the sketchbook. Since he is asked to find out the determine the inclination with respect determine the inclination of the surface of the lamina with respect to VP. So by using the protractor, keeping it on the AF of the second position top view with respect to the XY line, you measure this angle which will be equal to 44 degrees. When you are doing it in computer, you will going to get 43.85. How do I know that the problem is right? So we can see the edge which is on VP is inclined at 45 degrees to HP, since it is the true length and the inclination given is true inclination. Therefore, we are rewriting the same sketch by rotating at an angle of 45 degrees. And the side opposite to the side is 30 mm in front of VP. You can see that the side opposite to the side is C dash D dash, that is CD is in front of VP by 30, and it is the hexagonal lamina of 25 mm side. Since we have considered all the data which was given in the problem, and hence our problem is right. Thank you.